It's actually fun to look into the audience to see how many challenged faces I see in the audience. So we have a pretty big community at DARPA now of people who've got experience in the area. So I think part of what we'll do is have a conversation here today. We'll all get a chance to talk. We've got some sort of ghost of Christmas past, ghost of Christmas present, and ghost of Christmas future up here. So I'm from the past. You may know I was at the DARPA 40th birthday. I was at ETO at that time, and I had some job. It was a small thing compared to what's going on today. DARPA 50th, we spent a lot of time trying to get the Grand Challenge car into the hotel where Dick Cheney was speaking, and we couldn't get it in the hotel. We couldn't get it on the street where he was speaking. The Secret Service was just not interested in our idea. And so here we are at DARPA 60. I was the program manager for the Urban Challenge. Earlier than that, got this phone call that changed my life from Ron Kurjanowicz. Ron was after Jose ran the first challenge, it was a Stuckey for the second challenge. He was the program manager for the 2005's Grand Challenge. Ron gave me a call, and I got in my car. Reverse didn't work in my car. I ended up having to drive into my backyard and tear around, so I never got into reverse, went all the way to DARPA, and thank God I did that and didn't blow up the meeting. And sort of got involved in the first challenge, which I thought was kind of crazy. But I was sort of lead contractor for that one, and then was the program manager for Urban Challenge. And then involved in, you saw some of the other ones that they showed, the Shredder Challenge. We did that. It was a real small scale thing, but that was basically somebody had a bag full of shredded materials. We talked to the people who had been trying to piece together documents in Iraq. And we said, oh, maybe we could help them with this. And so we had a really interesting and successful challenge. It was won by a gamer and his girlfriend and his other best friend. They were the technology the guys that we attracted who actually made that happen. We did you saw what was the network challenge, was the red balloons. That was actually on the birthday of the internet. So it was an intern challenge. We had military interns helping us do it. Every birthday party needs balloons. So we got 10 big weather balloons, big red ones. Harry was involved with that. The first ones we ordered had DARPA logos on them, and we put them up out behind the old DARPA building, and they looked like a big eyeball looking around. So we pulled those all down, ordered new red balloons, and deployed them across the country. And the question was, how long would it take some team using any means to tell us where the 10 are? It was kind of originally an ISR challenge, but it turned out to be a social media challenge. I was really interested. They told me not to say this, but the first balloon was found by the psychic team. Psychic team found the first one. They found it almost immediately by guessing that it was close to San Francisco. Almost no one else could find that balloon because it was Christmas time and there were big red things everywhere, so no one noticed the red balloon among all the decorations in Ghirardelli Square. Since then, there's been a number of different challenges, as you've seen. Let me tell you from my perspective what was going on then. From the 40th to the 50th to the 60th, the real first innovation and challenges was Rick Dunn, who was from a support office at DARPA. He was the general counsel of DARPA, and he did a lot of work to get prize authority for DARPA, and that was actually the key. The prize authority was DARPA's attempt to reach out and build a more diverse participant community. And that is really what's been happening. I think that when we look at the history of DARPA in the future, we're going to see, the swerve in DARPA history. DARPA went from a funding agency, which has, a bunch of guys with bags of money, and women with bags of money, and performers, and the only thing we need to do is choose performers and tell them to go do something. When we got the prize authority, when we started the challenge project, suddenly there was another player. There was a role intermediate between those where DARPA was sort of a catalyst in bringing people together, either in the form of a challenge. This has led to Chris White setting up the Summer of Data next to DARPA in a building. There's been a number of different kinds of ways that we've sort of brought people together and tried to organize communities more than just dropping fundings in the right place. So there's something subtle and something very, very important about the way that challenges have changed DARPA. And so even the big outreach that you see in something like this today compared to DARPA 40, completely different. We went from being very introverted, I want to say, to being a much more outward-facing agency. So this has been a sort of a fundamental and extremely important step as the department tries to build a bigger community of performers, get more diverse performers, tap into the energy that's in private industry, but not necessarily being funded by the government currently. So it's really been a big, big step. So challenges from the video, it looks like they're good for a lot of things. You could use it for almost anything. We're going to maybe open the book, open the kimono, and take a look now by talking to some of our panelists about what happens when you really run a challenge. What is their story? We've got 3 great speakers. Everyone's going to take a segment to tell you their story. The first is Dave Hall. You may recognize him from the Grand Challenge days. You've seen the spinning Velodyne. He's the inventor who invented that Velodyne. Currently still working it, and he's our representative from the participant community. He's going to tell you how you get rich and famous by participating in a Grand Challenge, and it's all true. Mike Walker, Mike, he's ran just very recently the DARPA Cyber Challenge, and Todd Master has a challenge that he's currently spinning up. So you're getting past, present, and future through our panelists. So let me first invite David to tell his story.
Hi, I'm David Hall. I'm the founder, CEO of Velodyne LiDAR, among other projects. So I was involved in all 3 of the Grand Challenges. In the first one, I had my Team Dad truck, which I think was 3rd off the line. And we all stopped in a row, so I was 3rd, stopped behind a rock for some reason. And I actually know why. So if we take the car apart, about a few years later, we found out the bugs that were actually in it. So I could explain a few years later why my car stopped there. And then the second Grand Challenge I showed up with my LiDAR. And I did that with, I really thought long and hard about the lessons learned in the first LiDAR, because I'd gone there with a state-of-the-art stereo camera that I thought was the right answer. And I found out with my camera I could see all the road some of the time, some of the road all the time. I could never see all the road all the time. And the challenge was 10 hours long, and some of it was in sunset. So, and I listened to all the guys complain about or talk, because it was a very social gathering. We're all marooned out there in the desert, and we're all sharing stories because we'd all developed these cars. And there was a lot of time to kill because you had something to do once a day, and the rest of the time you're chatting up with new guys you met. And most of those guys I met, still in contact with today, and they form the group of most of the people doing anything in an autonomous vehicle were at that first challenge. And in retrospect, I call it the Woodstock for nerds. And I don't think there's been anything like it since. And it was a pleasure to be there, although the environment of the dust was kind of awful, actually, in hindsight. But a lot of the problems that I looked for, so I was looking for a new business to get into. I was in the audio business, the speaker business, and doing a lot of manufacturing, and a lot of that manufacturing had gone overseas. So I was looking for a new product line to take advantage of the manufacturing I had. So I went into the challenge with Tony saying that, hey, we're going to be autonomous by 2015, and this sounded like a big project. And maybe this had some, dig into that and maybe find something to build. So, going into the first challenge, nobody really had any idea what anybody was up to. And so you're really up there and you wonder if you're state of the art or you're going to look kind of silly. And so we all got up there a little nervous, and then we eventually got to know where everyone was at with the state of the art. So the second time around, it was a little bit, you know who you're competing against and what the level is. But a lot of the problems that I studied was this conflict of these false positives, which were bothering everybody, and nobody had a solution for this. And also, nobody actually thought it could be done anyway. So we were all thinking that, yeah, we're showing up, but in reality, there's no way in hell this is ever going to work. And I thought, well, let's not be that negative. So then that gave me the inspiration to come up with a rotating LiDAR as a way of reducing false positives and as a way of showing a picture that if people could see the environment from top down instead of forward, that they could see that they could solve the problem. So that was the inspiration I had to make the LiDAR, and I was building it the last half of 2005, I guess. I kept imagining how great the picture was going to be when I finally turned it on, because it was 6 months to put it together, and then 3 weeks before the race I turned it on, and then I finally got a picture out of it, and the picture did not disappoint me, by the way. So I was showing up for the second race knowing that there was going to be a third race because it had already been announced, and a $4 million prize, and I said, okay, $4 million, now we're talking some real money here. So then as it happened, somebody won the prize and the race was canceled, and then I went to DARPA and complained to Norm, among others, that you really needed a third race to show off what could be done, because you'd gotten this whole industry spun up, ready to, really chomping at the bit to invent this stuff, and with one more challenge, you could really show off what the potential was. And then Norm came up and used, with my prodding, came up and organized the third challenge, which I think was a great success.
It was all you, that's
No,
what I remember.
no, I just I chewed the DARPA people out for getting us all spun up and then pulling the rug out from under, offering this $4 million and then taking it back. I think that's what it was. So since the time, and then you saw all my spinning things, and so I was at the third challenge as a vendor only, and biting my nails, hoping none of my LiDARs would fail during the race. Of course, everybody assumed that if I was going to enter the race, I would have put in a little time delay disconnects that would shut them off. So nobody wanted me to be a competitor, so that was all right with me. So in the time since then, LiDAR was first used by, my products were first used for mapping, which wasn't anything that anybody considered a LiDAR for, but that was the first 5 years was, the growth was fueled by mapping companies. And then in the last 2 years, the self-driving industry has really taken off a life of its own. And in some ways, I would say this is predictable in that there always was, for anything consumer, there's this 10 or 20 year time frame between when you introduce something and then it dribbles along and then it hits a knee and it goes up like this. And this was explained to me back in my 20s when I went to a seminar very similar to this, where a guy was explaining that you have to wait your 10 years before the knee happens. And then a lot of people go 9 years and then they get disgusted waiting for the knee and they drop out. And then there's a whole other business section that waits for the knee to happen and then they jump in. And that would explain the 42 competitors I have that are trying to make LiDARs that are trying to kick me off. So, but there has to be a patience between when you invent something and when it becomes accepted. There's a time, and I always knew this was going to be 10 years, and I just hung in there waiting to pay my dues until the 10 years are up, and now I have a pretty nice, pretty good position and a pretty nice company from it. So,
How big was the team when you built the first LiDAR? How big were with you and who else? The first LiDAR.
Well, I was running the audio company, so I corralled all my audio engineers. So I had about a half a dozen engineers working for about 9 months nonstop, making the first LiDAR, the big wheel that was on the Team Dad truck. And the audio business suffered from that. But I could do that because I was the boss, so I could. And then when we went to the race, it was just me writing the code, and my brother was there. So we had the slimmest. Maybe we had one other person, but. There was kind of a contrast between, in the second challenge anyway, there was me and my brother, we were there, and then Carnegie Mellon was there with about 100 people, so there's us two, and then versus 100, which was fun. And a lot of the excitement of the project is I don't do work for DARPA, and I've actually never taken any DARPA money, but some of the attraction was the pomp and ceremony associated with it. And so I had done the Robot Wars contest and the fighting robots, and found out that as an engineer, if you ever have an opportunity to be on TV, you should take it. So that was my goal in life, is because as an engineer, you can actually make it through your whole life and never be on TV. So at first I was in the Robot Fighting Wars, and that was great because you could see yourself on TV. And then when the Grand Challenge came out, it was clear that this was going to be covered by the press. And that was the most important thing that I had, that I was going to go into it, that I was at least going to have something that my kids could watch me on TV again. So this was so the things I got out of the Grand Challenge were the fact that it was going to be covered by the press, and And then also the camaraderie of finding people that had the same interest I did.
Do you think it was important to have 3 challenges? Was that too many? Were people exhausted? How did that work for you guys?
Well, you wouldn't want to have 4, and 2 didn't get the job done. So I think 3 is the right number, and maybe it's 2. It's never 1. 1 is not the right number, because the 1 is just when you get together and you sum up your competition, you find out what it's really going to take to have a contest. So that's what you're doing, is everybody's getting on the same page. And then the second one, you actually have a contest that's meaningful. And then maybe you have a third one once you really figure out what the problem is. And some of the self-driving things was, what actually can we do versus pie in the sky stuff. So the 3 is not a bad number, but 1 is a terrible number, and one will never work.
Interesting. So I first met Mike when he came to DARPA and gave an amazing talk on cyber competitions, human competitions. And he kind of stimulated a whole bunch of thinking. So maybe you can tell us what your story is, Mike.
That was my first exposure to the agency, was giving that talk. And it's worth talking a little bit about how that talk came about and what the expectation that me and my fellow reverse engineers had when we brought it to the agency. So in 2010, there were a lot of headlines about cyber workforce development in national security and how we were going to build a cyber workforce, the tens of thousands of positions, how to scale it, and potentially the impossibility of scaling that workforce. And at the time, I was a leader in a computer security research lab solving national problems every day. But I hadn't gotten there simply through a professional track. I had also gotten there through a competition track, because the hacker community had been busy building and refining the rules to adversarial computer security competitions called capture the flag competitions for 20 years by that time. And it was that competition circuit that kind of brought me into my professional career. Going and playing in the World Series of Hacking at DEF CON Capture the Flag was how we built workforces that were effective at this work, how we recruited, how we trained. It was everything. And we built this presentation that basically said, if you want to build an effective computer security workforce, the way to do it is through constant competition. Be like us. And we took that presentation to a number of government agencies, one of which was DARPA. But at DARPA, what happens is people who are fighting the battles of the present are suddenly confronted with people who are always thinking about the future. And what Director Dan Kaufman and Deputy Director Norm Whitaker said to me was, "That's wonderful, could a robot play?" And that was such a shocking moment. It was a question I had never contemplated. And I had no answers, but I was immediately skeptical. And the process of becoming a PM to run a grand challenge was the process of me talking myself out of my own skepticism. Using data and using the incredible leverage of the DARPA PM office to go out and talk to experts. And I never had an expert say, of course you could build such a thing. I got quite the opposite, just existential resistance. No such system is possible, but. And if you took everything after but and kind of cobbled it together, what you got was an autonomous system that just hadn't been built yet. So the process of designing Cyber Grand Challenge and executing it over 4 years was not the process of figuring out what that technology is like, which is the classic DARPA role, is making the planning and execution decisions for a new technology, but instead setting up a series of existential gates where if such a technology existed, it would be able to do these things. And then building a challenge program using prize authority for a set of global competitors to go through those gates and prove that such a technology was possible in limited steps. So by the time we had a field of 7 and gave them their own supercomputers, we knew that they could autonomously comprehend binary software with no source code, that they could find novel bugs, and that they could patch it. And that if we could put them into competition against each other and let them autonomously practice their own adversarial game theory, that we would have a moment where the world could settle the existential questions of, is autonomous cyber conflict possible? And that's exactly what DARPA got.
Back in the day, we used to talk about challenges. There was this notion of a tournament versus a race. One idea is that you say, okay, let's make a prize for the first guy to get to the moon or something like that. It might take 10 years, maybe they'll never make it, but every year we'll appropriate the prize money and hope that someone eventually gets it. Very difficult to run that kind of thing because of this appropriation challenge. Alternatively, you can have a tournament, which means everybody shows up, a little bit like your event, and whoever is the best on that particular event, they get a prize. And the risk there is that they may all be terrible. So Tony actually kind of put together the hybrid. The original hybrid was with both of those things. It was a tournament which had much better sort of PR value. It was a date certain when you were going to have something take place. But also he set a level of achievement. You had to complete the course. If you didn't complete the course, then no prize. So that kind of protected the taxpayer money from giving out a bogus prize. So Mike, you didn't have how did you know that they weren't going to all be terrible? How did you sort of engineer the...
And I think the movie said it, right? Every challenge now has this DNA to draw on. So we drew on that DNA. We had a qualifying round and a final round. And part of the purpose of the qualifying round was to authorize the final round. So there was a set of outcomes where we had could have had no viable technology show up to qualifiers, and that was the end, and there was no finals. So what we said was, we're going to give, in 24 hours, we're going to give automated systems 100 pieces of software, which was an analysis task of sufficient scale that no human team could have competed. You had to have an autonomous system to do 100 challenges in 24 hours. And when we got a qualified field of competing systems that could all do some functional reverse engineering autonomously of 100 pieces of software overnight, and actually only picked the 7 best. We had competitors we had funded and competitors we didn't fund, and we got kind of a 50% knockout ratio. Half of the people we funded were eliminated by completely unfunded teams. But that 50-50 balance of funded, unfunded, all showed that they could perform the basic tasks necessary to have a tournament. So we knew by the time we had a tournament scheduled a year out from there that we were bringing 7 viable autonomous systems with wildly different approaches.
You imposed a go, no-go on yourself.
Yeah.
Good DARPA style.
You don't want to have a challenge where no one can play, a tournament where no one can play.
Right.
So we started up that qualifiers knowing that in 24 hours the whole thing could be over, and not knowing what we were going to get.
That's great. Okay, the ghost of the future is Todd. So Todd, why don't you fill us in? What's
Sure.
the motivation behind your challenge? What is it called?
Sure. Yeah.
Get everybody excited.
I can give a little background on it. So I'm running a program called DARPA Launch Challenge. So I got to DARPA in April 2016 and inherited a program called ELASA. The goal of ELASA was to demonstrate flexible and responsive space launch. And it was not DARPA's first attempt at doing this. We'd been doing it actually a series of programs over the span of almost 30 years. It started with a program called Pegasus, continued with a program called Taurus, both of which were technical successes, but never really got widespread adoption by either DoD or the commercial industry, primarily because they were just much too expensive. We continued on with a program called Rascal, which had some technical challenges, and we actually canceled that fairly early on in its life cycle. And then I inherited ELASA, which was our approach to trying to put 50 kilograms in orbit from an F-15-based launch system. Again, we ran into some technical challenges. As I like to tell people, you can almost put something into space with an F-15 and the right launch vehicle underneath, but it requires a very energetic launch vehicle. So you either have to figure out a way to squeeze performance, or use lighter structures, or use a more energetic fuel, and that's exactly what we chose. And challenge with an energetic fuel is very energetic. So we wound up blowing up a few engines before we figured out that we weren't sure exactly on the right technical path. So that program got de-scoped, and we really did a lot of investigation into exactly what was happening with the fundamentals of the propellant. But it sort of left us in a quandary of what should we do next. And the reason why, I would think it's not very typical of DARPA to continue on a thrust for a particular capability for such a long period of time, but we continued to see a shift that we wanted in the way that we use space as part of our vision for the future of space. in a vision where we're going to use space a lot more responsibly and a lot more tactically. Today, we really use space still in a very much strategic way. We build big, expensive space systems. We use them for a long period of time. They primarily support, theater-wide needs or global intelligence goals, but we don't really use them in a way that we're supporting tactical warfighters or supporting tactical operations, or we're not deploying things really on need. We're building systems that are projected for future use, for strategic use. And we really wanted to shift to that philosophy. So we had not given up the ghost on trying to pursue flexible and responsive space launch. We really wanted to drive that cost down significantly, and technology continued to progress. And that was part of it too, was we kept seeing new technology solutions emerging. After we would end one program, it was, new technology was emerging, and was like, well, let's try it again. So in the instance of after the cancellation of ELASA, what was really interesting was not only the emergence of new technology, but a new interest from in space in general, in the public view. And as a result, a big interest in space in the investment community. So we saw last year $13 billion in private investment in space, unprecedented amount of investment in space. So that was sort of a game changer. And as a result, that was also, we saw over 50 different commercial companies who were pursuing small launch vehicles. And what was interesting out of these companies is the goals of what they were trying to do with their vehicles were very closely aligned with a lot of what we wanted to do at DARPA. They were looking at low cost, frequent cadence, having no particular reliance on a fixed range infrastructure, which typically is sort of limiting from an agility standpoint. They supported a lot of what industry was doing was closely aligned with what we wanted. But again, there were over 50 companies at various stages of maturity. But it sort of set up the right conditions of how do we take what these folks are promising, which is closely aligned with what we want, and get it to a point where they can actually deliver something that's useful to DoD to meet our goals. So when I looked at it, we wound up having a workshop actually with as many of these companies as we could sort of find or approach, and at various stages of technology development, some of whom had been at it for a long time, some of whom had a napkin and an idea. And talk to them about, how do we get your idea from where it is to fruition? Because we want what you're selling, but we don't know how to make this work in a way that's mutually beneficial. And so we got a variety of inputs from that workshop, but a couple of things emerged, and one of them was an endorsement from the U.S. government or the Department of Defense was really important to them. That helped them attract more private capital, which helped them build their business. So that was something that we sort of took away as an interesting factor. And it was also the potential for future government contracts was something that was really interesting too. So we were trying to figure out a way that we could take those inputs and put that in a useful way, and I approached my boss and said, what about the idea of taking a grand challenge model and applying it to space launch? We can put up prize money, we can set up a set of conditions that would reflect the future state of how we would like to use space more tactically, responsibly, and it sort of took off from there. So what we stood up is something called DARPA Launch Challenge. So at the end of 2019 is when we're going to execute our challenge, the last quarter of 2019. And competitors in the DARPA Launch Challenge will have to launch 2 spacecraft to orbit from within a period of about 2 weeks from different launch sites, different orbits, different spacecraft. The real hard part about this, that as if that wasn't enough, is that they're going to have very minimal prior knowledge of what the system is that they're launching, where they're going to launch it from, and where they're going to launch it to. So this all imposes a lot of a lot of hard problems, but it very closely reflects the way we want to use space in the future. We can imagine a future state where we suddenly want to put up new intelligence, new ISR capabilities, or new tactical support capabilities, but we didn't know when or where that was going to happen until it actually happened. There was a military need somewhere on the globe that we were then going to follow. So that's really how I sort of structured DARPA Launch Challenge to reflect those goals closely. But it has some unique aspects as opposed to, I think every challenge has unique aspects to it, and some of the ones that are different from our prior. So we spent a lot of time looking at our prior challenges, how we executed those, what was successful, how you set up the rules, and how much money you have to apply for a prize to make it compelling. So we looked at all of those sorts of things. So DARPA Launch Challenge has some unique aspects. It is the largest prize authority that we've issued at DARPA. If you complete your first launch, competitors win $2 million. Once they complete the second launch, our top prize for the second launch is $10 million. So you can win a total of over $12 million if you're the top finishing team, significantly more money than we've offered before. And there's a good reason for that, is a launch vehicle development costs significantly more money than a self-driving car, or not to disparage self-driving cars because they're awesome, but space systems, even on the sort of new edge of things, are still are larger in scale, more complex, cost more money. So we had to put
12 million is a lot of money, but compared to a VC who's writing $100 million checks,
yeah.
How do you still attract attention even with
so
with
we
that
had
much
to.
money?
So and it was clear, when we looked at it, we said, is the top winner, depending on where they were in our competitive field, wouldn't necessarily recover 100% of their costs. And we had this discussion with all these teams. We sort of floated the amount of money that we thought we were capable of putting up, and that made sense. And we looked at, and I think for a lot of teams it was okay, because it was not necessarily that they had to recover 100% of their costs, but they had to recover enough to make it attractive to their investors. But the part that I think most of our teams are interested in, I will put words in their mouth to the extent that I can, and you should talk to the teams if you really want to find out. But I think what they see is the real value in what we're trying to do is we are trying to demonstrate a capability to the rest of the Department of Defense that the paradigm that we're in today, where you build spacecraft on multiple year cycles, you plan those on multiple year cycles, which, as if you saw Dr. Kennedy's talk on enterprise disruption this morning, we're very interested in shattering that paradigm, and this is one of the ways that we can do it. So I think competitors in the challenge see that that's coming. They see that there's a lot of thrust and interest in the DoD, and if they're the ones who are able to successfully demonstrate it, they know that that puts them at the forefront of recognition for DoD and a huge upside potential for future DoD contracts, in recognition of their put up or shut up, we actually did it capability. The money helps. The money helps pay for hardware and people and all those sorts of things, but I think a lot of it is really the promise of future business. And I think that's something that's a little different in what we're trying to do than what we did in other challenges. I think when the commercial transition path and the military transition path to a successful competitor at a DARPA launch challenge, I think is a little bit more clearly defined than what we did in some of the other challenges. So I think it's easier for them, both in the, there's a lot of investors putting money into this already, and the potential future business upside for them in the future. I think that's why we think it's going to work. I will say we've had a lot of interest from industry. We're already sort of in our pre-qualification phase, where we're looking at teams have to submit sort of an initial application which explains their approach. It's sort of a low bar for entry at this point, which gets raised to a much higher bar by the end of the year, when they really have to provide a lot more evidence of that approach. At this point, it's more, describe your approach. Is it sound? Does it match what we're trying to do? Are you going to be technically mature enough by the end of 2019? When we actually, so a lot of teams are making it through that process. When we actually really start to dig into the details of, well, show me how you're going to get there, that's when I think you're going to see a whittling down of our teams. But
so there's a little bit of cost recovery. There's sort of the DoD affiliation and accreditation.
Mm-hmm.
There's some additional synchronization of the field, or tell us about what else does DARPA bring to the table? I mean, because we could just wait and say, well, Elon will figure this out. Eventually, we'll buy it from Elon. That's what we'll do.
We could wait. And that was a discussion that we had, is, if you sit back and wait, would this just happen? And my argument on why I don't think that approach is going to work for us is I don't think that we're sending off these commercial teams on an entirely different path than what they're on. I think they're on a road, and we're trying to steer them a little bit slightly off of that path, but to something that supports our goals. So very specifically, I think most of the commercial launch companies that are out there are developing capability because they see a commercial future. And that commercial future today, at least, and for the foreseeable future, is very, very well planned. It very closely mirrors the way that we use even big launch vehicles. It says, well, a communications company or an imaging company comes in and says, in 2 years I'm going to launch 3 satellites, and they're going to go to this orbit, and they plan all those sorts of things. So I think absent our influence on this, they would continue to design systems that would potentially be cost-effective for small launch, but they wouldn't necessarily be particularly agile or particularly flexible in the way that they plan their operation and their integration. And that's the thing that we really want to send the demand signal that, hey, keeping your system, keeping those aspects is something that's important to DoD, and we're willing to put up money to make them.
This community building aspect,
Mm-hmm.
We were talking about this earlier. My picture of the Urban Challenge has something like 700 people in it who participated in some way. And Dave sort of has the, what happened 10 years later. The cost recovery piece is all forgotten at this point. But what's the vestige that remains 10 years later when the industry kind of takes off, Dave? in terms of the camaraderie or the community that's been built. Can you talk about that for a minute?
Well, other than everybody working in the industry, we all know each other. We know the capabilities, and there is a little bit of still competition going on between the various teams. So there's still a little bit of a the people working on this stuff, and there's a little bit of trying to do a little better job than the next guy. So the whole spirit of competition is there's still a residual of that in the industry today.
It seems like if we had just let a couple contracts for self-driving cars and paid people's expenses 10 years ago, we wouldn't have got this effect. This wouldn't have taken off and built an industry like it's done today.
Well, you wouldn't have my LiDAR, that's for sure. And whether or not, certain things went ahead. You have the Mobileye, the camera, and the lane following, and I think that would have happened anyway. But there's a whole. Everybody believes now that someday the world will be free of accidents. And so that's starting to impact some people that are concerned that too many people die on the highways.
It's a shared hallucination, that we're going to be living in this world, and that's actually very, very effective because people make it come true.
Well, that's starting to become a motivator now to actually carry the ball across the finish line. Is this humanitarian effect that the byproduct of actually the grand challenges? Nobody really knew that we were going to actually solve that problem accidentally.
Yeah.
So sometimes you have a fallout from these contests you can't even anticipate, and so some of what the Grand Challenge had is it announced that the military was interested in a consumption of a project, and I would never find that out on my own. I don't read what anybody in the military is thinking or buying, and unless the military suggests and raise a flag saying that, hey, I have a future market for this, I'd never know about it. So a lot of the attracted me was the military says, hey, we have a market for this thing because we have a need for it. And I says, well, if there's a need, I'll be a supplier.
Yeah.
And so the same thing with your rockets is, although there are commercial events, but you have to say with the military has a need that actually nobody in the commercial space would ever find out about that unless it's advertised.
Can you talk a little bit about and you've sort of insinuated a little, and obviously I kind of know, which is part of the reason why we really wanted you on the panel. Can you talk about the growth of your company, kind of so you started out with your brother building speakers and you invented a new product for this, but...
When I visited you, I saw just you and some pieces of shop equipment inside a speaker company. That's all I saw. It seemed like it was a very humble beginnings to me.
Well, the speaker business treated me well, and so I lived a good lifestyle on that. And but I got a little bit burnt out when the business left the United States, and I became an importer rather than a manufacturer. And so my genes are inventor, and it's very difficult to invent here when all your manufacturing is some other god-awful place in the rest of the world. No offense to the rest of the world, but. It was quite the shift that caught me unprepared, because I would have thought that I could have kept manufacturing speakers in here up until today, and as it turns out, that what happened is all my suppliers got wiped out, so that there wasn't anything I could buy here in the United States to make a speaker unless I imported it, and then everything had to go through a container and shipping, and it was just a nightmare to try to import individual parts. So. But nevertheless, the speaker business was pretty robust, and I was known around the world for selling subwoofers. So I was a subwoofer king, and so I was able to run both businesses simultaneously, which isn't anything that I actually recommend anybody do. Because I had engineers, and I said, well, an engineer, you can design speakers one day and a LiDAR in the afternoon, and then it's like, well, no, not quite. You had people that were in love with speakers and people in love with LiDARs, and they really didn't get along. But
I remember the speakers that damaged the foundation of your house. Isn't that what?
Yeah, I was famous for that. And it's
can you talk about the market penetration you've made with Velodyne? And I think some folks in the room are probably familiar with how it's being used, but I don't think a lot of people are with
well, I sell most of the
today.
LiDAR used in autonomous vehicle research today. So I have, and the business is pretty robust. I mean, it's a unicorn plus business these days. So I ship to, I sell all the LiDARs generally used in offshore, and then there's a lot of activity in the German and European space, and then of course I supply everything or most everything Elon is the only guy that doesn't buy my LiDARs, so he's a holdout. And
You'll survive.
he'll survive without me. So I'm sure he'll be just fine. So I don't worry about him. And also people use these LiDARs for other things. There's guys that load ships they can measure how much coal is in the hold using my LiDAR. And there's about maybe 100 or 200 offshoot little projects going for safety and for measuring. And somebody has it on, we have a drone model that flies around and makes a map, so you can take off your drone and you can fly it around your building and land it, and you have a full 3D map of your building. And that's a nice little business. And then there's almost too many offshoots now for me to keep track of, so the industry has spawned all this new mapping and other activities. And there's some autonomous ships things that I think use my product. I don't know, somebody...
Active?
I don't know, somebody, I don't know. I can't keep track of them all. So right now the autonomous vehicle is certainly driving the value of my company up and keeping us full-time busy as the industry is really gearing up to actually manufacture and mass produce self-driving cars.
How many people do you have now?
Well, last count there was about 700 in the factory, all totaled, and about 120 of those are research engineers. So I'm pretty heavily working on the next generation LiDARs, so we've got all kinds of activity, and pretty high-end activity.
I like that it's a decade narrative. That going from speaker manufacturing to $1 billion laser imaging business was not an overnight achievement. And I think that was one of the things that I was so surprised at Cyber Grand Challenge was we've got an entire marketplace now of people who study software as their profession, and an entire consumer marketplace hiring experts to study software. And the day after the Grand Challenge, when suddenly we had the first autonomous systems that could do this, you could go hire a robot to check your software. I think in the minds of many of the people interviewing me, it was done. That was it. And I was trying to say, no, there are going to be billion-dollar businesses, and they're 10 years out, and we have the history to prove that.
Well, we had somebody try to buy the LiDAR business, I don't know, 6 years ago, and he offered $6 million, and we said, you know, hey, I spent way more than that building this LiDAR business. I'm not going to pull the rug out from under it now. I think I'll just wait a while for the business to take off. So I hadn't waited my 10 years. So, you know, it's a problem about, you know, you go through this trough of disillusionment, and this 10 years is a long time, but you have to wait the 10 years, because my theory is that people generally don't like change, but once they change, they don't change back again. So this is why you have a knee. First, there's this nobody believes in self-driving cars, and then there's this turning point right where we're at now, where everybody believes in it, and then they want it, and they can't get it soon enough, and that's where we're at right now, and that took a 10-year period. And that's actually pretty fast. So I would say that we're probably ahead of schedule on my 10-year minimum wait between when you introduce a new idea before everybody accepts it and can't live without it.
So in Silicon Valley, where you guys are, the sort of dangle of $100 million, VC dollars that are around, how does DARPA compete with that in your view? How does $1 million look?
Well, my experience in shopping my company and others is that there's really a lack of good ideas out there, and there's way too much money chasing way too few ideas, and that there's a real need for somebody to identify what the new big businesses are, and the VC community is really bad at that. And so my side profession is I bash VCs anyway. I have VCs in here, so I don't have any VC dollars in my company, so I feel obligated to say that I think you have a problem here, and that the United States there's not enough good ideas floating around, and we've seen a lot of good ideas come out of DARPA, and I think you ought to keep turning that crank, and because I don't think private industry is coming up with enough to rejuvenate the place. So certainly the way DARPA announced and the great Grand Challenges worked, the real inspiration was that, hey, this is if you build it, they will come. If you build a self-driving car, there'll be a market for it. And certainly nobody in the 2000 timeframe had any idea that this was worth working on.
So Mike, I got an email, which was a PDF of some congressional language, which, and there was a yellowed out part that called out Cyber Grand Challenge by name and said, why has this not been inserted into the governmental security apparatus. What's going on with Cyber Grand Challenge? Where are we? Who's incorporating it? What's the productization path? How's it going?
So it's funny, the congressional language continues to change. I think we've gone from where is it now to a line item for autonomous cloud-based fuzzing of entire software stacks. So it's moved into procurement language, and that's probably good.
But before that, it started with why are we paying for this, right?
I'll say that when you become an advocate for a technology that does not yet exist, that you spend a lot of time paying down existential debt, right? Yes, it can exist. Here is the technology proof. It's not time travel. It's based on real technologies. They need to be assembled and prototyped. And you do a lot of communicating as a DARPA PM. But there's no communication device as powerful as a moment where something works and people can see it. And I remember someone associated with the Vehicle Grand Challenges telling me that the moment you see a 10-ton truck come over a hill with nobody steering it and it makes a turn correctly, that the hair on the back of your neck stands up and you're kind of transfixed by that moment, and you can't not believe in autonomous vehicles after that. The problem with the computer security domain is it's really easy to get lost in the words. And communication of what was happening there involved investing in communication. You know, if you hear, we're going to autonomously fix vulnerabilities, most people will say, well, that happens for me automatically every Tuesday. And what they don't realize is that there's hundreds or thousands of people writing the patches that are being automatically downloaded onto your computer. And then an automated system that could do the identification of the flaw, triage the flaw, analyze it, write the patch, autonomously synthesize the code that would fix the security problem, do it all in a matter of minutes and ship it out. That's a new thing. And if you understand anything about computer security, it's also one of those hair on the back of your neck stands up moments. So we had to invest in communicating that this was a new thing and letting people kind of inside that world, you know, see that these were novel problems. And in that moment, can this system exist? That existential debt was paid out. So now, you know, immediately after the challenge, there is this small community that came out of colliding a whole bunch of different communities. You know, collide the hacker community, the program analysis community, the formal methods community, slam them all together, give them a goal, let them prove that autonomy is possible. And what has to happen now is that decade-long walk of market matchmaking. You know, products need to be put forward, and there are commercial products. Microsoft has a commercial product. For All Secure has a commercial product that can autonomously check software, autonomously suggest fixes, emit the proof, eliminate the false positive problem. How that's going to come to be consumed is, as you've seen, is going to take a long time. Both for the market to shift towards automation and what it can achieve, and for people to gain confidence in the technology iteratively.
You know, you brought up the communication issue, and I always think that's really interesting. The research part of DARPA, you know, Advanced Research Projects Agency, the research is largely an education function. The job is to put a different thought into the people's heads. It's not to build a prototype. It's to demonstrate enough so that people think that something's possible that they didn't realize was possible. And so that's, you know, it's debt that you're paying, but actually that's the job. That's not friction. That's actually the job, is to put for an urban challenge, that was kind of the vision. The vision was, we're so scared of these cars in 2005, you know, they kill you. Wouldn't it be ridiculous to have like a city street with them running around? How about that idea? If we did that, then that would change the world, we thought. And so it was literally the picture of that we wanted to convey in all senses. We wanted the PR to be there. We wanted we wanted it to be something people could witness, you know, not something that happened and we reported that happened. People need to see it, and they need to viscerally understand it in order to see that a completely different world is possible. So for you, you know, you kind of exist in this world of, you know, SpaceX and Blue Ocean. How do you? What's the survival mechanism for swimming in such the shark-infested waters? Yeah,
so we're seeing a lot of momentum in commercial industry towards, and even you're seeing it in the way that Congress is authorizing future launch vehicles, a big focus on reusability. And at a large scale, reusability is really important because it does. If you've got a reusable launch vehicle, you can get to really efficient utilization of cost. The problem with that is what that sort of ignores is those reusable vehicles are inherently not particularly agile or flexible. They want to come back to the same. They want to come back to the same launch site they launched from. They've got an exquisite launch infrastructure which is set up to do that turnaround. So there's cost, but there's definitely benefits there that help you realize really, really good costs. I like to kind of compare what we're trying to do with responsive launch and small responsive launch with and what the big guys are doing on sort of reusability. It's sort of the city bus versus Uber model, right? The city bus is a really cost-effective way to get across town if the bus is going to where you want to go, when it's going to, it's leaving when you want to go, it's going to, the final stop is where you want to get to. That works great, and it works well for things like deployments of big constellations of spacecraft or monolithic single spacecraft launches. But when I have something unique that I need to put in maybe a different trajectory, a different orbit, and maybe there's a hurricane at Cape Canaveral this week, so I can't use Cape Canaveral, or maybe we're in a military situation where I don't want to use a coastal launch site this week because I'm concerned about terrorist or adversary attack.
There's a reuse metric. Is there a speed that they have to be able to get it back up?
I mean, so we're not focused on reusability. We're focused on expendability because at the cost scale that we're looking at, I mean, so what you have to realize is that the typical large launch vehicles are on the scale of, it typically used to be $150 to $200 million. The likes of SpaceX and Blue Origin have brought that under $100 million. But we're looking in order of magnitude less than that. We're looking at under $10 million per vehicle. So less capability, but significantly lower cost. So it's they're sort of apples and oranges in some ways. I think they're both important pieces of the puzzle. I think they're going to solve different military needs and different military challenges.
Yeah. It gets, the motivating the competitors, the participants, it's actually a big, big piece. And understanding the psychology is a lot of the work we did in the vehicle challenges. We actually did, marketing visits to talk to people and say, well, what does your boss think if you did this? Will he pay for it? And everyone told us, my boss said I can do it, but we have to win. That's what they would always say. And we realized, the thing about challenges is they create lots of losers. Everyone's a loser except the winner. And that was the origin of the three. DARPA normally says we don't care about anybody's second place and below are dead to me. We just care about the winner. That's sort of the DARPA style. But we softened Tony on that one to give us first, second, and third. It was because of the marketing study to say that we were not understanding the motivations of the participants. That was actually an important piece.
And we have a first, second, and third prize, and it's partly because we looked at prior challenges. And it is sort of the tyranny of a typical procurement is, DARPA determines what the statement of needs are, right? So we put out a BAA and we say, these are all the things we want you to do.
Yeah.
And we communicate with industry before that to try to see what capabilities are, but sometimes that can ignore a possibility that we may have thought of or an approach we may have thought of. And then we do a downselect based on the proposal that was submitted. Some companies may be particularly great at explaining their idea, and others may be really good engineers who don't write particularly good proposals. So those people in a typical procurement process could get missed. A challenge really is exciting because it rewards results, right? You might not be able to write much of a proposal, but if you can build a LiDAR that works, or you can launch a rocket to LEO twice in 2 weeks, you can walk away with the prize money.
Yeah.
It's really interesting that you continue to focus on why the military needs this and articulate that military mission. And that's something that resonates with what David said is, I chased this self-driving car star because I knew the military needed it. But what's funny is 10 years later, the massive market that exists for LiDAR is mostly commercial. Mm-hmm. There's this enormous commercial use, and I have to wonder, have you thought at all about how this $10 million space launch is going to transform the commercial world?
So, it's a little bit almost of the reverse, is our competitors have figured out that if they can do that they've got a commercial market. And that's the reason why we're able to do this now, is because with the amount of money we're putting up, we could not, a company I would contend could not get started, have the amount of money to build their business and do this in the time frame that I had requested. If there wasn't already industry momentum based on a projected commercial market, we couldn't do Launch Challenge. But that's why it's interesting to do it, because that commercial market is nascent. It's actually projected. The military need for that is not yet projected, but we at DARPA see that as part of the future.
It's kind of one of the fundamental parts of what makes a great challenge is there's symbiosis of need. Yeah.
That's right. And like I always say, you need to find a parade and jump in front of the parade. Trying to create a parade from scratch is really hard. You need to figure out what people are individually all thinking about, and then say, oh, let's go in that direction. And they'll say, oh, that was just what I was thinking. If you don't do that, then you spend a lot of money and energy trying to get people to move. So we're pretty close to the end. I want to say thanks for your attention. We are sort of on our way now with challenges. The incredible capabilities of DARPA, that intermediate space I was mentioning, between the funding and the participant, that area in between is really built on this tremendous DARPA latent capability that was here. All these military people and industry people and academic people, the CETA teams, the amazing CETA teams. There's people in this room who've participated in basically all the challenges. That amazing knowledge, Harry, I'm looking at you, and Kylie, all the knowledge that's built up is really what the challenge capability is based on. And you don't get that for free, and you can't just export it to some other agency. DARPA has a special capability in the challenges that it really needs to be sort of open about what it's trying to do with challenges, that it's really about building communities. It's not just trying to get more research for less money. That's one view of it, but I think that's a very narrow and a sort of cloistered view. Anyway, does anybody else have a closing statement you'd like to throw out there you didn't get a chance to say?
No, I think that there's, and we had a lot of discussion about this, I think even in our group too, that there's a set of conditions that make it work, and it's certainly, we could never switch to, DARPA's only going to do challenges from now on. That it's a diversification of the way that we do our research that I think when the conditions are right can be really fruitful.
Right. It can start a whole revolution, because that's the word everyone describes self-driving cars as, the self-driving car revolution. And that should always be considered the test.
It's the tip of the revolution right here in David.
Well, also economically during the challenge, I was adding up in my mind the advertising value I was getting for the dollar that I was investing. And I thought I was just about breaking even on it, because I did have a company and I didn't need advertising, and I saw the Grand Challenge as its coverage as being newsworthy. Helped me justify the cost and effort that I put into it. So if you have a challenge and don't tell anybody about it, it won't really work for my purposes.
Anyway, thanks very much.